Astrobiology Exploring Life's Possibilities in the Universe. Astrobiology Exploring Life's Possibilities in the Universe. Introduction. Astrobiology is a fascinating field that seeks to understand the origins, evolution, and potential for life beyond Earth. It delves into the fundamental questions of whether life exists elsewhere in the universe and what forms it could take. Through the interdisciplinary study of astronomy, biology, chemistry, and geology, scientists are pushing the boundaries of knowledge and exploring the vast possibilities of life in the cosmos. In this article, we will embark on an exploration of astrobiology, examining its history, current research endeavors, and the profound implications it holds for our understanding of the universe. The origins of astrobiology. The concept of life existing beyond our planet is not a recent development. Ancient civilizations looked up at the night sky and wondered if other worlds existed with beings similar to themselves. Ho. Weaver, the scientific study of astrobiology began to take shape in the mid-20th century. The discovery of exoplanets, planets orbiting stars outside our solar system, provided a new perspective. This sparked the imaginations of scientists and intensified the search for signs of life elsewhere. The search for extraterrestrial life. Astrobiologists employ a variety of methods to investigate the potential for life beyond Earth. One approach involves the study of extremophiles, organisms that thrive in extreme conditions on our planet. Another avenue of exploration lies in the search for habitable exoplanets. Scientists use telescopes to observe distant star systems, searching for planets in the so-called Goldilocks zone. This region around a star is where conditions are just right for liquid water to exist, a critical component for life as we know it. The exploration of Mars. Mars has long held the fascination of scientists and the public alike. It is considered the most accessible planet for human exploration and a potential abode for life. Several missions have been sent to Mars, including the Viking program in the 1970s and more recent missions like NASA's Curiosity rover. These missions have provided valuable data on the planet's geology and habitability. While we have not yet found definitive evidence of life on Mars, the search continues. The upcoming NASA Perseverance rover aims to collect samples that will be returned to Earth by future missions for more detailed analysis. Life in extreme environments. Astrobiologists have found life thriving in environments previously thought to be inhospitable. From the depths of the ocean to the scorching heat of geothermal vents, extremophiles have challenged our understanding of where life can exist. Such discoveries have expanded the cosmic neighborhood where life may be found. The possibility of subsurface oceans on moons like Europa and Enceladus has further fueled the search. These subsurface oceans, warmed by tidal forces, may harbor the conditions necessary for life to emerge and evolve independently from life on Earth. Biosignatures and the search for life. Detecting the presence of life on other planets or moons is a challenging task. Scientists are working on identifying biosignatures, indicators that suggest the presence of life. Biosignatures can be chemical, such as the presence of specific molecules or isotopic ratios, or physical, such as patterns in the composition of rocks. Biomarkers, such as the detection of specific molecules associated with life, are another avenue of investigation. The development of new technologies and instruments, along with advancements in our understanding of life's diversity on Earth, will aid in the search for these elusive signatures of life. Implications for the existence of extraterrestrial life. The discovery of extraterrestrial life, even in its simplest form, would have profound implications for our understanding of the universe. It would suggest that life may be a common occurrence throughout the cosmos, rather than a rare exception. The potential existence of intelligent civilizations raises questions about our place in the universe and the possibility of communication with other beings. Astrobiology and the future of space exploration. Astrobiology is an integral part of planning future space missions. By understanding the potential for life beyond Earth, scientists can target their efforts towards locations with the highest probability of harboring life. Mars is a prime target, given its similarities to Earth and the tantalizing clues it offers. Astrobiology has captivated the minds of scientists and the general public alike, as it seeks to unravel the mysteries of life beyond our planet. This multidisciplinary field draws upon the knowledge and expertise of astronomers, biologists, chemists, and geologists to explore the vast possibilities of life in the universe. By examining the origins, evolution, and potential for life elsewhere, astrobiologists are pushing the boundaries of our understanding and reshaping our perspective on the cosmos. The concept of extraterrestrial life is not a recent development. Ancient civilizations pondered the existence of other worlds and beings similar to themselves as they gazed up at the night sky. It was in the mid-20th century that the scientific study of astrobiology began to take shape. The discovery of exoplanets, planets orbiting stars outside our solar system, ignited the imaginatio of scientists and intensified the search for signs of life beyond Earth. Astrobiologists employ various methods to investigate the potential for extraterrestrial life. One approach involves studying extremophiles, organisms that thrive in extreme conditions on Earth. Another avenue of exploration lies in the search for habitable exoplanets. Scientists use telescopes to observe distant star systems, searching for planets within the Goldilocks zone. This region around a star is where conditions are just right for liquid water to exist, a crucial ingredient for life as we understand it. Mars has long been a focal point of exploration for astrobiologists. It is considered the most accessible planet for human missions and a potential host for life. Previous missions, such as the Viking program in the 1970s and NASA's Curiosity rover, have provided valuable data on Mars geology and habitability. Although definitive evidence of life on Mars eludes us thus far, the search continues. The upcoming NASA Perseverance rover aims to collect samples that will be returned to Earth by future missions, offering unprecedented opportunities for further analysis. Astrobiologists have also made astonishing discoveries of life thriving in extreme environments on Earth, where it was once thought impossible. From the depths of the ocean to scorching geothermal NTS, extremophiles have challenged our conceptions of where life can exist. These findings have expanded the cosmic neighborhood where life may be found, even within our own solar system. Moons like Europa and Enceladus, believed to harbor subsurface oceans, are prime targets for further exploration. These secluded aquatic realms, warmed by tidal forces, may provide the necessary conditions for life to develop and evolve independently from life on Earth. Detecting the presence of life on other planets or moons presents an immense challenge for scientists. They are working tirelessly to identify biosignatures, which are indicators that suggest the sense of life. These signs can be chemical, such as the presence of specific molecules or isotopic ratios, or physical, such as patterns in rock compositions. Biomarkers, such as the detection of molecules associated with life, also offer a promising avenue of investigation. Advances in technology and our growing knowledge of life's diversity on Earth will undoubtedly enhance our ability to search for these elusive signatures of life. The existence of extraterrestrial life, even in its simplest form, would revolutionize our understanding of the universe. It would suggest that life is not a rare exception but rather a common occurrence throughout the cosmos. The possibility of intelligent civilizations raises profound questions about our place in the universe and the potential for interstellar communication. Astrobiology also plays a vital role in shaping the future of space exploration. By understanding where life is most likely to exist, scientists can focus their efforts and resources on locations with